Hello, today we're going to be talking about naming compounds. The last section in 18.3. We talked about chemical bonding in the first one, so now we're going to talk about how we name them. We know how and why certain elements combine now. It's basically because they want to fill their outer shell, their valence electrons, to get 8, and so they'll combine so they can be in a compound where they're more balanced, they're more likely to have that full outer shell. But where do we get their names from? The first thing we're talking about is ionic compound naming. Remember, an ion, it actually steals an electron, and so you have a negative a positive, which is the cation, and a negative, which is the anion. And they join first. And when we name them, we always put the cation first. Good news, then the bad news. So the cation goes first, and then the anion, which is typically your nonmetal, comes last. Down here at the bottom, it shows sodium chloride. Sodium, right, is our metal, and our chlorine is our nonmetal. Okay, and then we change the last syllable of the anion, the oxygen. Say if we're going to do some oxygen or chlorine, we're going to change the chlorine to chloride. And so once we get that done, we write down the name sodium chloride. Here are some rules for writing the formulas, especially when it comes to ionic ones. The overall charge has to balance to 0. That is the most important thing to do with ionic bonding. Start by looking at the elements that you're given. The easy thing to do is to make sure you have a copy of your ionic compounds. Here's the periodic table of ions, and it shows you that over here on our family 1, our alkali earths, they all have a +1 charge. And then as we go to the right, they have a +2 charge. We can skip over the transition metals because it shows the different various charges that are inside there, which explains why it's kind of hard sometimes to deal with valence electrons with these guys. And then we go back over to boron here, and we can see that it only has a couple of +3s. Notice carbon in the middle. We talked about how it has 4 electrons. Carbon and silicon tend to be very neutral, whereas we get to the lower half, we get germanium, and then there's different variants. We have different types of tin, different types of lead, and those will be +4s or +2s. And then as we continue to the right, we go -3. So over here under nitrogen, those are all the starts of the negative ions. -3, oxygen is -2 for the most part. There are some rules once you get past notice right here, the stair step is our nonmetal and metal dividers, our metalloids. And you'll see down here below, the bottom ones tend to act as your metals, and the top ones tend to act as your nonmetals, which shows by their charge. And then we continue on over to our halogen group, which is over here with our -1s, and then we have our stable non-ionic noble gases. So we have a copy of this. This will really help you when you're trying to figure out your charges and all that kind of stuff. So look at those elements and you see what their ion charge. We also call that an oxidation number. Remember, oxidation has to deal with the loss or gain of electrons. Okay, and that's shown there on the chart, whether it's -1 and +2. That would be your cations and your anions. And now you have to basically combine the elements to get an overall charge of 0. Remember, ions have a neutral charge. There's no positive or negative when you have a ionic bond. So you have to make sure that you get the right amount. So we look here, we use what's called the crossing method. We have lithium and we have nitrogen. We look back over at our chart right here. Lithium is a +1 and nitrogen or nitride is a -3. So we know right away I need to have 3 lithiums, 3 +1s to make +3 to balance out the -3. And the crossing over method, what that does is it merely takes the 3, it's a +1 over here, the -3 here, well, you just cross the numbers over. That lets me know I need 1 nitrogen and 3 lithium because nitrogen was a -3. So I need to cross over and give those to the bottom of the lithium. So I get 3 of those. And that's what's called the crossing method. Just kind of depends on how your brain works with math, which way works better for you. All right. Now we're going to talk about the naming. First off, remember, we got to figure out how do we know if it's ionic. Well, remember, it's ionic if you're combining metals and nonmetals. Okay, we have our negatives and our positives. Okay, and if you look at that periodic table down here, it kind of shows that coloration difference. Then you also have your anion periodic table that will show you. Remember, you always write the cation first, the metal first. Then we go to the non-metal and we change that word to "ide" instead of bromine, bromide. Here's a little kind of quick cheat chart right there. So practice a little bit. We have calcium and chlorine. Well, we're going to look and see calcium. Calcium is our metal. Okay, it's right here. And chlorine is our non-metal, so it's calcium chloride. In the formula, then we'll check to see calcium. If you remember, the second column is a +2, and chlorine over here, I believe, are -1s. Yep, so we need 2 chlorine molecules and 1 calcium molecule. So the formula then would be, that's right, Cl, or Ca1Cl2. Okay. And that continues on with oxygen, potassium, and boron, and sulfur. You can work that out. Here is a picture of what's going to look like when we do the worksheet in class, and we'll kind of walk through these together in class. The polyatomic naming. So once we get done with ionic charges, we have what's called polyatomic ions. Okay? And the ionic bonding with those, they're special ions that commonly form in nature that are made of 2 or more ions together. And they're typically not easy to separate. If you look back over here, at the very top of this periodic table of ions, it shows this table of polyatomic ions. These are things that are naturally formed in nature as an ion already. It's polyatomic, which means it has more than one atom, more than one element already combined. And you can take these and combine them with other elements. Okay? Good old chemistry. And they are typically not easy to separate, which is why we leave them together. They form like that and they are stuck.
Please excuse the interruption, everyone.
So the rules for polyatomic ions is that polyatomic ions must be kept together when writing the formula names. You can't split them apart and drop something down in the center of them. You can never, and they're put inside of parentheses so that we know, hey, this is a polyatomic ion, don't mess with it. So you never, ever, ever change anything inside of parentheses when it comes to naming or writing the formulas. Remember, the overall charge must balance to 0. This is still an ion, so we have a 0 charge. And we always write them with parentheses with the charge on the outside. So for instance, OH, which is a hydroxide, I believe. Double check. Yeah, hydroxide, and negative charge. All right, so, and it has a -1 on the outside. You don't use "ide" on the anion name, you just leave it as it is. NaNO3 is sodium nitrate, not sodium nitride or sodium nitritide. Okay, so once it has that polyatomic, you would just name the polyatomic, so it's sodium, and then the name of the polyatomic ion. We don't change it. All right, here's some practice that we'll be doing in class. Go ahead and work on that if you'd like. One of the things that we do with ionic bonding in the transition metals, because they're so weird, we have all these different charges. Iron, for instance, down here has a +2 or a +3, depending on what kind of charge it is. So with the transition metals, they don't play by the rules, so sometimes there can be many different ions for one element. So what we do is we write down the charge of the ion, and we use Roman numerals for this. So the rules are that you use Roman numerals in the name to show the charge of the ion. So that would be iron 3 or iron 2. Okay. We work backwards when writing the formulas. You write down how many ion you have, and then you figure out the charge of each ion. So iron ions like Fe3, we don't call ironide, we just call it iron 3. Okay, we put the Roman numerals behind the name, just like that, iron 3. Okay. And remember, an iron has many different ions. So simplify the formula at the end if you can. If you have 2 of one element and 4 of the other, that can be simplified down 1 to 2. Don't leave it, right? Always simplify at the end. So for instance, copper 2, all right, we know that is Cu with a 2+, okay? That's titanium 4, all right, and so on and so forth. And here's some stock system practice that we'll be doing in class, just to kind of give you an idea of what's going on. After we get with the ions, we're going to get down to covalent compounds. So covalent compounds, remember, share their electrons. how do you know if a compound is covalent? Well, remember, covalent compounds are usually made of metalloids and the nonmetals only, just a small group on the right in that diagonal portion of the periodic table of the elements. Okay? So when we name covalent compounds, we use prefixes on both elements. Okay? The prefix is shown in this chart over here, and if it has a one atom, it's mono, two di, three tri, four tetra, five pentahex, so on and so forth. Okay? And the only time that you would not use a prefix if there's only one of the first element. For instance, BF3 is a boron trifluoride, not monoboron trifluoride. So we never use the prefix on the first element if there's only one of those, okay? Which is why it's dihydrogen monoxide, okay, for H2O. The element farthest to the left is listed first. Just remember, even though hydrogen over here with the metallic symbol, hydrogen is a nonmetal. It is a gas. Okay? The element farthest to the left is listed first. So we have nitrogen and oxygen. Notice they're right next to each other. Well, we go nitrogen because it's listed first in the periodic table. It's number 7, and oxygen is number 8. So we have dinitrogen tetraoxide. Very good. Here is some naming practice, and there is a link down here that you can watch that will give you some more information on naming.